The following question reads that there is a solid cylinder is lifted out of oil by a wire attached to a motor and shows two different positions of X and Y of the cylinder during the lifting process. So this is a cylinder that was dipped in oil, and remember, oil is going to create an upthrust. I mean, there's going to be the weight of the cylinder that is going to be acting downwards. And this weight of the cylinder, this weight is pointing downwards. This would be counteracted by the force. Remember, the motor is pulling this object upwards. So there's going to be tension in the wire, and there's going to be a force that would be applied that would be in the upward direction. Plus, there's going to be an additional force that would be the upthrust of the oil. The oil would also be pushing this piece of cylinder upwards. So if I balance these forces, weight would be pointing downwards, the tension in the wire would be pulling it upwards, plus the upthrust of the oil is going to be pulling it upwards. So let's call that U. So it's going to be W would be equal to F plus U plus upthrust of the oil. Whereas if you look at the second diagram, you'll notice that the cylinder is no longer dipped in oil, which means that the upthrust that the oil was exerting or pushing this cylinder upwards, there's not going to be any upthrust. So the upthrust would be missing over here. There's only going to be the weight of the cylinder that would be pointing downwards, plus the force or the tension in the wire that would be pulling it upwards. So over here, the force of the pulley upwards would be equal to the weight of the cylinder. The condition is that the forces must be in equilibrium, which means that the cylinder must be moving. There should be no overall acceleration. If there is overall acceleration, that means there's going to be a net resultant force. So over here, the velocity is given as constant, and over here, I think the velocity is also given as constant. Is given as a constant. Let's read the question further and figure that out. If you read the next part of the question, the motor is fixed to an overhead beam. The cylinder has cross-sectional area of 0.18 meters per second square. Length is 1.2 meters and weight is 560 newtons. So a lot of information is provided in this part. The weight is given as 560 newtons. So we know the downward force that's acting. The length of the cylinder is given and the cross-sectional area of the cylinder is given. So we can figure out the volume of this cylinder using these two values, because volume is cross-sectional area into length. So if you multiply the two, you will find volume. And the density of the oil is also given. It's given as 940 kg per meter cube. Now, based on these two informations, we can figure out what volume of oil must have been displaced. What volume of oil would be displaced? Anyways, reading further, throughout the lifting process, the cylinder moves vertically upwards with a constant velocity, which means that all the forces are balanced out. There's no net acceleration. It's a constant velocity, which means there's not going to be a resultant force. The viscous force of the oil acting on the cylinder is negligible, which means there is no drag force. This cylinder is slowly moving out of the oil. So we are assuming that one force is absent, which is the viscous force. The viscous force is, if you move an object out of a liquid, the liquid is going to drag it downwards. So if you move this object upwards, there's going to be a drag force. So the question states that there is no drag force. Now the first part is we need to calculate the density of the cylinder. Density is, the formula for density is mass over volume. So we're going to use that formula. We can figure out the mass of the block of cylinder. If you look at the mass of the block of cylinder, remember, for this cylinder we were given the weight, and weight is W is equal to mg. So you're provided the weight, and weight is W is equal to mg. So using this formula, we know that the weight is 560 newtons. Mass would be into 9.81. So if I rewrite the formula, I can substitute the value of mass from this, and it's going to become my density my density is going to become, it's going to be, the mass would be 560 divided by 9.81, and I need to divide it by the volume, and the volume we already figured this out. The cross-sectional area of the cylinder was given and the length of the cylinder was also given. So we need to multiply the two. It's going to be 0.018 multiplied by 1.2 meters. So if we do that and if we calculate this, this is the value of mass that we got from this W is equal to mg equation. The length, area and cross-sectional area gave me volume, so density is equal to mass over volume. And my answer for this is going to come out to be equal to 2600 kilogram per meter cube. In the next part of the question, you're being asked for the cylinder at position X. So the cylinder at position X, show that the upthrust due to the oil is 200 newtons. We need to find the upthrust due to oil. So going back to my diagram, if you look at the diagram, and this is the cylinder that's at position X. So if you look at the diagram, the first thing we need to know is how much oil is displaced, because the upthrust is caused by the displaced oil. So we need to figure out the amount of displaced oil. Now the amount of displaced oil would be equal to the volume of the cylinder. So the volume of the cylinder is already known. It's cross-sectional area into length. So that is given. So we would be able to figure out how much oil has been displaced. So the volume is going to be 0.018 multiplied by the length, which is given as 1.2 meters. And this volume comes out to be equal to 0.0216 meters. So this is the amount of oil that has been displaced. So I've copied my working over here. So the volume of oil displaced is 0.0216 meters. The other thing that's given is the density of the oil. So over here, the density of the oil is given. Remember, density is mass over volume. Using this formula, we know the density of oil, which is given as 940 kilogram per meter cube. So that's provided. So I'm going to take that 940 kilogram per meter cube, and I'm able to figure out the mass because the volume is also known. It's this should be meter cubed. It's 0.0216 meter cubed. So using my formula for density is equal to mass over volume, I can figure out the mass of oil that has been displaced. So mass of oil that has been displaced is 940 into 0.0216, and the value comes out to be 20.304 kgs. So this is the amount of or the mass of oil that has been displaced by the cylinder that's been dipped into it. Now upthrust is equal to the weight of oil that has been displaced. We know the mass of oil, which is coming out to be equal to 20.304 kg. So the weight would be m into g, which is the mass is 20.304. I'm going to multiply it by gravitational force, which is 9.81 meters per second square. So my answer would come out to be approximately equal to 200 newtons. So this would be my upthrust, and this is how I've proved it's equal to 200 newtons. So this is the solution for this part of the question. In the next part, we are being asked to calculate for the moving cylinder at position X the tension in the wire. So if you go back to our diagram, you would have noticed my working earlier as well. This is the tension force that is being applied by the wire upwards. It's in the upwards direction. Weight is downwards, and then there is upthrust. So I wrote down an equation that weight of the cylinder is equal to force, which is the tension in the wire, plus the upthrust. So these two forces are in the upward direction. The weight is in the downward direction. So using this this relationship, I'm going to figure out the force or the tension in the wire. I know that the weight is 560 newtons. I know that the upthrust is 200 newtons. So this is what's happening. W weight, which is 560 newtons, should be equal to the upthrust, which we calculated in the previous part, is 200 newtons plus the tension T in the wire. So this is the rough diagram that I've sketched. Weight is pointing downwards, wire tension is pointing upwards, and the upthrust, the liquid oil, is also pushing this object upwards. And solving for T now, tension T would come out to be equal to, it's going to come out to be equal to 560 was the weight, 560 minus 200, which would be equal to 360 newtons. In the last part, part 2, the power output of the motor is to be calculated. We know that the object is moving upwards at 20 meters per second. So we know the velocity with which the motor is pulling the object upwards. Let's go back to the diagram and recheck. Yes, over here, it's if you look at the diagram, the motor is pulling the object at 0.020 meters per second. The force or the tension in the wire, we already calculated, that came out to be 360 newtons. So we know the force and we know the velocity as well. So let me first correct this. It's 0.02 meters per second. So power, the formula for power is force multiplied by velocity. The force is 360 newtons. And the velocity with which the motor is pulling the object upwards is 0.020 meters per second. And this value comes out to be equal to 7. If you calculate this, it's going to come out to be equal to 7.2 watts. Moving to the next part of the question. The question now is that the cylinder is raised with constant velocity from position X to position Y. State and explain the variation, if any, of the power output of the motor. As the cylinder is raised, numerical values are not required. So what happens as the cylinder is pulled out of the oil? Remember that there was tension T in the wire. There's tension T in the wire. There's W, the weight of the object, and then there is the upthrust caused by the displaced oil. So as the cylinder moves out of the oil, less oil would be displaced. So less oil is displaced. And if less oil is displaced, that would mean that the upthrust is going to decrease. It's going to be lesser. So since the weight is equal to the upthrust plus the tension T in the wire, the motor is pulling it upwards. So upthrust and tension T, those are the forces in the upward direction. The W weight is in the downward direction. So weight is equal to upthrust plus tension T. Now upthrust decreases as the cylinder moves out of the oil. Less oil is displaced, so upthrust is decreasing, which means that for the motor to pull up this weight, the tension T must increase. So this should be increased. It would become more difficult for the motor to actually pull this cylinder upwards because the upthrust value is going to be lesser. So more tension, more force needs to be applied by the motor. So if more force needs to be applied by the motor. So what would it do to the power output? Remember, power was force into velocity. So if you want to keep the velocity constant, the force is constantly increasing. So the power would increase as well. The power output of the motor, more power from the motor must be used. So power output would also, it's also going to increase. So you're going to answer this question in 3 points. The first point would be that the upthrust, less oil is displaced. So the upthrust is decreasing, which means that more force, you can use this relationship and you can then talk about more force needs to be applied by the motor. And if more force is applied, then the power output, because power is force into velocity, the power output of the motor is going to increase. Now in the next part of the question states that the rate of energy output of the motor is less than the rate of increase of gravitational potential energy of the cylinder. Now remember, this is weight. This is the gravitational potential energy. This is you're doing work. and you're increasing gravitational potential energy as you lift this solid upwards. So weight, you're doing work against this W. But remember, work is being done by the motor, but it's also being done by the upthrust. Some work, because lifting the object, the upthrust is also contributing. It's also lifting the object. So some work is being done by the upthrust. So the motor over here is pulling the object, but the upthrust is also adding some work to it. So the motor has to do lesser work. Less work would be required from the motor, which is why the increase of gravitational potential energy of the cylinder is greater, whereas the rate of energy output of the motor is lesser. So less work would be done by the motor.